All right, everyone, here is your review sheet key, video key for PA8 to PA13. I've already completed it, so I'm going to try to make this video a little shorter. There's a more in-depth video with all the work shown from the group test, which either you have taken already or maybe you haven't taken it yet, depending on the year. But let's get to work on this. So first, we're evaluating f of 0. Which means this is an x value. Up here, you have to pick the appropriate piece, either the green piece or the purple piece, based on the value of x that you're plugging in and what this part tells us x is allowed to equal. So here we're allowed to use x values that are less than or equal to 3. Since Rx is 0, which is less than 3, we're allowed to plug in 0 for this x. And so that's what I've shown here. You can't plug in 0 into the purple part because you're only allowed to use x values that are bigger than 3 for the purple part. And that's why for this one, we're going to use the purple because 5 is bigger than 3. For C, f of 3. So this is where it's exactly equal to 3. And so just use the appropriate piece based on where it's underlined. Since x is less than or equal to 3, we're going to use the green piece for that. And here's my work with me plugging in 3. And then finally, part D is find the value of x when f of x equals 2. So that's a y value. So what we're going to do is find the x value and then see if we're allowed to use the x value for that. So I'll let you take a look at the work here, but I set the green equation equal to 2, found x. I set the purple equation equal to 2 and found x. X is negative 3 halves, come up to the green part. And if negative 3 halves is in fact less than 3, then that answer we're allowed to use. And it is, so we are allowed to use this one. The purple one, we have 5/4. If 5/4 is greater than 3, then we can use 5/4, but it's not greater than 3. So this doesn't work as a solution. So we don't actually get to use that, but you do have to find it and see if it can be used. It is possible to have both of them work. Oh, actually, no, sorry. It's not possible to have both of them work because then it wouldn't be a function. So if you know one works, then the other doesn't. But I want to see you checking them both to make sure. Oh, sorry, I misspoke again. It is possible to have two. You can have this x and this x have two different y values. On a graph, those are just like next to each other like this. So two different x's for the same y is fine. All right, on number 2, we're using a graph to do the same questions. I've highlighted the points over here that we're using, but you're given a y value here, given a y value here, given a y value here. So you add the corresponding x values that we've already plugged in there. And then on D, find the value of x when f of x equals 2. So I've kind of highlighted this horizontal line right here where x equals 2, and anywhere that the y value is 2. So I called this approximately negative 3. It's close enough. Right here where I've highlighted in green, and then also right here at x equals 6. So you get two answers in this particular case. You wouldn't always have two answers. Like if I said, find the value of x when f of x equals negative 7, for example, well, negative 7 is down here, and that would only hit that particular point right there. All right, now to graph, I graphed the entire lines to show you what the entire line looks like, but the dash part is the part we would erase after graphing the entire line. So I'm going to explain it two different ways. A purple part, I'm going to graph the entire line. So I started a y-intercept of negative 4 and use a slope of negative 1. So you can go down 1 over 1 or up 1, left 1, and you can keep doing that to create more points and then draw a line through that. But we're only allowed to use the purple line starting or ending, actually in this case, at x equals negative 2. So we have to use x values that are less than negative 2. So you start at this point, and we can only use points that go this way. So none of these actually exist. The other way to do it is, now we're going to switch to the green line. The green line, in this case, starts at x equals negative 2. And so you can plug negative 2 into this, get your y value, which is also negative 2 when you plug in negative 2. And the green line starts here, and then you can use your slope of 2 and go up 2 over 1, up 2 over 1 in this direction because we have to use x values that are bigger than negative 2. Notice how the green and purple meet at the point, and the purple point does exist, so overall that point just exists, so you don't see a hole at all. All right, solving equations. I showed most of my work here. Just get x by itself, so subtract 3, divide by 2 on that first one. On number 5, there's a lot of things you could do first. I like to keep my x's positive, so I'm going to move this x over here by subtraction. At the same time, I added 12 over there, and then you can divide. This one, since there's a number here, don't divide by this, just distribute first, which is what I've shown here. And then we do have like terms, which I combine to get 35, and you can look at the work of the solving from there. On 7, again, I would distribute this, and then this negative also gets distributed, which changes the signs of everything that's on the inside. So that was a negative, becomes positive. That was also a negative, becomes positive, and then you can solve it from there. On this one, if you want to get rid of fractions, first multiply everything by 2. So look how I showed this by 2, this by 2, this by 2, and this by 2. And that'll get rid of this 2 right here. Okay, so here's what I've done in the purple. Then, that's having multiplied everything by 2. Then I got to get rid of this 5, so then I multiply everything by 5. These 5s cancel, and then 5 times 3 became 15. 5 times 14 became 70. This just becomes 4 because the 5s cancel, and then that became 10. And then I'll just let you look at the work from there, but I combine like terms and then solve it from there. That's definitely the trickiest one right there on number 8. Number 9, solve inequalities. So I've shown this a little differently from the year 2024, but if it's the year 2025 or beyond, I've explained this differently in class. So I'm going to show real quick over here, when the x is negative, we want to add this to the other side. So it becomes 4 is less than 2x plus 22. Then subtract 22, giving us negative 18 is less than 2x. And then divide both sides by 2, giving us negative 9 is less than x. If you just read it this way, x is greater than negative 9, that's the same thing over here. This uses a trick that I have decided not to teach anymore in that manner. I think it helps avoid a mistake. Okay, 10, I'm just going to let you look at that one without explanation in the video. 11, the blue one is fine with how you've seen it. The purple one, though, since we have a negative 3x, the first thing I'm going to do, I'm going to change the work that you see on the sheet right now. I'm going to add 3x, so 8 is greater than 3x minus 7. Then add 7, so you get 15 is greater than 3x. And divide by 3, so you get 5 is greater than x. And so if you read it starting with x, you get x is less than 5, which is the same thing this says. Everything else is the same beyond that. And then on number 12, I erased the number because it looked like it was part of the problem. Now on this one, I will show you the trick, but if you want to do it like every other problem, just ignore this and then solve this one just like we solved this one. And so you get a one answer there. Then ignore this and solve this inequality the same way we solved by adding 3x over here first and then going from there. The trick though is if you want to keep it in between, if you want to keep the x in between things, get rid of the 5, so subtract 5, and that's what I've done here. And then I'm going to divide by negative 3. But I'm sure some of you heard in the past when you divide by a negative, you have to switch these inequality symbols, which is what I've done here. Because essentially dividing by a negative is the same as turning it positive, but when you turn it positive, you have to move it to the other side, but then you have to move it here. So it gets a little weird when it's in between two things. So on that one, there's the shortcut in case you were interested. On 13, okay, remember this is the distance from 0, and it has to be 14. Either 14 to the right or 14 to the left on a number line. And then you just solve from there. On 14, again, the number is erased because it looks like it's in the way a little bit. We're going to make 14 look like number 13. Again, oh, sorry, this is fine. So I subtracted 5, and then to get me this, and then divide by this negative 3 to get me this. And now it's just like number 13. We want the distance to be equal to 9 in either direction. So 9 to the right on a number line or 9 to the left on a number line is all the negative 9 actually means. Okay, jumping down to 15 now. Now, the same thing as before with equations for absolute value, but it's our distance from 0 has to be bigger than 105. So you let the distance be more than 105 to the right or less than negative 105 to the left, because on a number line, if this is 0 and then negative 105 is right here, we want to be more than 105 away. So you got to go this way, like negative 106, negative 107, etc. So you have to be less than negative 105 so that your distance is more than 105 away on a number line. And then you can solve those two like that. 16, same thing as 15, except now we want our distance to be less than 33. So you make your distance less than 33 to the right, but then it's got to be more than negative 33 to the left, because again, if it's negative 33, over here is 0, less than that distance of 33 would be these numbers, negative 32, negative 31, negative 30, and so on. So you have to be greater than negative 33. And again, I would add this to both sides first, add this to both sides first, or you can subtract the 15 and subtract the 15, that's fine. So we can start on this line right here if you want. But I would subtract or add the 9x to both sides. So giving us 0 is less than 9x plus 18, and then subtract 18, and then divide by 9 to get you that. And again, if you read it this way, that's the same as this one. And then over here, starting with this one, add 9x. So you get 0 is greater than 9x minus 48. Subtract or add 48, so you get 48 is greater than 9x. And divide by 9, so 48 over 9 is greater than x. And once again, this is x is less than 48 ninths, x is less than 48 ninths. So those are the same thing indeed. And then finally, this problem right here. So make this one look like 15 and 16. So you got to get rid of the 12 by subtracting 12. Now I'm going to show you something different starting right here. Since this whole absolute value thing has a negative in front of it, instead of doing this and trying to switch this to help avoid the mistake people make, I'm going to add this entire thing to the other side of the inequality, and then I'm going to add this one to that side. So it becomes 32 is greater than positive 2 times the absolute value of 6x minus 14. Do not distribute in absolute values. Leave that 2 there, leave that 2 there. To get rid of it, divide by it. So now you have 16 is greater than absolute value of 6x minus 14. And now we can do our two cases, which is, oops, I need absolute value, 6x minus 14. There we go. And now our distance needs to be less than 16. So we can do 6x minus 14 is less than 16. And that just means to the right. And you can do 6x minus 14 is greater than negative 16 to the left on a number line. And then I'll let you kind of figure it out from there. The work overall is similar to this. Actually, once we get to this point, they are exactly the same. So now you can just look at the rest of the work. And that's it.